Hi, I made a mistake when going over problem 6 with at least one of the classes, maybe in math help. So I wanted to correct that mistake. And since we're not meeting again before the test, I thought I'd make a quick video. We're supposed to find a function that connects the height of the Christmas tree with the cost for a given height. And we're told there are no trees that are below 6 feet tall. So the smallest tree we have to worry about is 6 feet tall. A 6 foot tall tree is going to cost $40. It's 3 feet above 3 feet. So it's 6 minus 3 times $5, which is $55. So we know a $6 tree costs $55. And let's go jump up to say an $8 tree. That's 40 plus, now it's 8 minus 3. An 8 foot tree is 5 feet above 3 feet. So that's times $5 per foot above 3 feet. That's 25, that's $65. So you could use 2 points, for example, to compute that. In the graph here, this second point would have been right here. So that would be 8 comma 65. And to find the slope of this thing, not surprisingly, if you go through the calculation, you'll find you get 65 minus 55, hopefully not surprisingly. 8 minus 6 is 10 over 2, which is 5. And that just tells you that the units for the slope would be dollars per foot, which is actually given in the problem. So you're actually given the slope, whether you recognize it or not. That's the slope right there. You should recognize it, knowing that this is the input and this is the output. If you're given a rate that connects the unit change in the output for the unit change in the input, or I should say the change in the output for the unit change in the input, that's got to be the slope. So right away you know it's C of h equals 5h plus, and now we need an intercept here. This is the part that I messed up in I think it was section 1 in math help yesterday. I didn't think very carefully about it. Actually, the intercept for this thing is really, it's not 40. It's tempting to think it's 40, but technically the function looks like this. It's C of h is equal to, it's 5 times, 5 times the number of feet above 3. So we have to subtract 3 from whatever height we have, and then that's plus 40. So that looks like the intercept here, but when we clean this up, you get 5h minus 15 plus 40. So the actual intercept is 25. You can see in the graph over here, that's this point right here. And so this is actually 25. So the answer is C of h equals 5h plus 25. The tricky thing about this is that we don't really care about anything except the Christmas trees between 6 feet and 12 feet. And you can, this is the lower limit because we're told there are no trees below 6 feet. The upper limit's up to you. I didn't tell you that. You can pick whatever upper limit you think is reasonable. I picked 12 feet. Even that's probably pretty generous. There are unlikely to be trees that tall on the lot, but at least we can price them if there are. You can pick whatever you like for this upper limit. There's no right or wrong answer as long as it's reasonable. If you put 500 in there, that's obviously silly, or negative, but something negative. But whatever points you put in, you just have to be consistent moving forward from that. So at any rate, all I care about is the price of trees that run between 6 feet and 12 feet according to the domain that I chose. So I chose a domain of 6 less than or equal to h less than or equal to 12. That's just the one I picked, and you could pick your own. 6 probably ought to be the lower limit, since I told you there aren't any below 6, but the upper limit's more or less up to you based on your understanding of how big Christmas trees get. The range then is going to be the range of outputs between those two numbers. So at 55, at 6 feet, you're at 55, which is about right here-ish. And 85 is, that's 80. 85 is around there. Not sure what that scaling is, kind of a strange scaling. That's your range. And so between 65 to 85. So 65 is less than or equal to the cost for a given height, less than or equal to 85. And again, this number will depend on what you chose for this number. As long as you're consistent, I've got to mark it correct. Okay, that's the right answer. The thing that you should keep in mind there is that even though this line only applies between 6 and 12, we still need this intercept to set that line, right? So you could argue that the price of a tree between 0 and 3 feet, if such a tree existed, would be $40. So you'd probably run a flat line across to here, and then starting at 3 feet, you start creeping up, going up by $5 for every full foot. And in between, it doesn't even really make sense. It probably ought to be a step function because you're not going to charge them by the inch. We're only going to knock the price up when it goes up another inch. So if you really think about this function, it's actually pretty tricky. And so this is sort of a crude representation of it. And so a lot of students say, well, why am I bothering to compute the price of a tree that's 0 feet tall? What kind of idiot would pay $25 for a 0-foot tree? Or for that matter, $40 for a 3-foot tree when they're not even on the lot? And the idea is none of these points matter. But this line right here needs some kind of base. So I have to know whether it's this line or this line or that line. And this number over here at the y-axis is what we use to position this line where it's supposed to be, right here. And that's what the intercept, that's the role the intercept plays here, even though it's not actually a reasonable output for the function. So these are the correct answers here. I hope that answers all the questions.